Very good evening, guys. How are you all? I am Manish Mishra and I welcome you all to this YouTube channel on Academy Gate Mechanical PI and XC. Good evening, Arunopal. Good evening, Nagarajan. Good evening, Ashwin. I am fine, Ashwin. How are you? Good evening, Sanjay. Nice to see you guys. Although I can't see you, I can just read your comments, but still, I feel like seeing the same names every day. I feel like students are there in my class. Thank you, Nagarajan. Thank you very much. Hi, Venkat. I am doing absolutely fine. Yes, I am very well now. I'm sorry to miss yesterday's session. I was very tired and I didn't feel like taking the class yesterday. So I thought, why not? Because Sunday usually we remain the class off, but this Sunday we had the class, so I decided why not take a break on the very Monday. So, guys, today is a new day, a new month, and we will be starting this new month with a completely new topic. Let me just plug in my laptop. It is giving me a signal that the battery is draining fast. Okay. Sir, industrial is my elective subject, but now I didn't feel so. I learned many useful things from one and only you, sir. Thank you, Ashwin. I mean, these nice words, they always motivate a teacher, and same is the case with me. I feel motivated when students like you always give me such good comments. So let's not waste any more time. We are having a good run and let's just make the most of it. So for those who don't know me, my name is Manish Mishra. I secured an all India rank of 568 in GATE 2015, and since then I have been teaching primarily for GATE. I have a cumulative experience of 5 years and the subjects that I primarily take are manufacturing, industrial, OR as well as material science. Very good evening, Sanjay Jaiswal. I was missing you. That Sanjay Gupta has came, but Sanjay Jaiswal is missing. So guys, just let me jump. Just let me jump. आई में आपने गर्दा उड़ा दिया है सर. What is garda, man? This is a new word. So, industrial engineering and operations research. We are currently. Sir, good morning, sir. I am facing problem in this. Please give a free mind. I don't know what you are asking. Okay, let's not concentrate on that. Now, so guys, today in this session, I will be starting line balancing. That is chapter number 10, line balancing. Today I'll be starting with this particular topic, and it is quite an interesting topic. So let's see whether you and I share the same interest or not, because there are certain things which I can enjoy, I can cherish, but it's not always the same for everyone. So let's just straight away jump into this. Let me just properly write the heading. Line balancing. Ashwin is looking for some Maggie story today. Ashwin, I don't know. Maybe. I mean, these stories are basically, what do you say? They come from inside. Yes, why not, Raju? Definitely, I will do that. Thank you, Ashwin. I'll try to give the real examples here also. Let's see whatever struck my mind. So, guys, let's just start. Let's just straight away jump into this and start. I wish to complete this topic today only. So, line balancing. Guys, how many of you have heard about assembly line? Or how many of you have even seen an assembly line, whether on TV or on YouTube or in reality? Okay, assembly line. I mean, even if you have heard this word ever, that would be sufficient for me because I will be explaining what is an assembly line. Anyone? Yes, Arunopal is saying yes, he has listened. He has listened. I and OR is like tasty, similar to Maggie. In TV, yes, sir. Sir, मैंने. Okay, 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 guys. Okay, 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 guys. Okay. So, see, basically, assembly line. What is an assembly line? Let us just cover this. Okay. So, guys, assembly line is like a moving workstation. Assembly line is like a moving workstation. Suppose this is a belt. Suppose this is a belt, and suppose this belt is moving in this direction. So this belt here is moving in this direction. Now, what happens? What happens that there are certain workstations. There are certain workstations that are along the movement of this line or this belt. Let me just name these workstations. Let's say this is workstation 1, this is workstation 2, and this is workstation 3. So guys, basically what an assembly line is, it is an efficient, to the point manufacturing process, or I should rather say assembly process. Whenever it comes to assembly, okay, so assembly basically means when I have to put things together. I have created stuff, I have manufactured stuff, and now I will just be putting them together in order to create a particular product, a component which can be finally sold. So suppose we take an example. Suppose consider the example of a motorcycle. Consider the example of a motorcycle. Now you all must have seen Hero Passion, one of the most popular motorcycles in this country, Hero Passion. So let's say if you will look at that motorcycle, Hero Passion, you will see a whole lot of different products on that particular motorcycle. A motorcycle is not like a single product, okay? I mean, it is an assembly of a lot of products. So a motorcycle has headlights, a motorcycle has a seat, has a tank, has a handlebar, has a chain, has wheels, has brakes. So there are a lot of things that we combine together in order to create a motorcycle. So guys, what happens is that all these small things, whether it is a mechanical equipment or an electrical equipment or an accessory, all these are first manufactured at some locations. I mean, if you will try to find more about this, you will get to know that Hero Motor Corp, they do not manufacture all the products or all the equipments that goes inside its motorcycle Hero Passion. I mean, a motorcycle has around 1,000 parts, and all those 1,000 parts, ranging from a very small nut bolt or a screw up to a completely full spec motorcycle engine. Now, all these equipments, all these thousands parts are not alone manufactured by Hero Motor Corp. There are different aftermarket suppliers, there are different agencies which we call as OEM, original equipment manufacturer, which Hero Motor Corp themselves give a contract or give a tender to manufacture certain equipments of its final product Hero Passion. So you can see that the headlight of the Hero Passion is manufactured by some other company. The seats are manufactured by some other. The, let's say, the brakes are manufactured by someone else. Okay, you must have seen that in most motorcycles, like even in pulsars or so, you must have seen that on the brake calipers there is what is that, Biber written there, Bybre. If you have seen that, you will know what I am trying to say. Biber is a small company created by Brembo is a very large brake manufacturer. Brembo manufactures brakes. Okay, I mean world class brakes. So Brembo is a very popular company who makes brakes for motorcycles, and Bybri is a very small division of Brembo that makes brakes for motorcycles that are used in common domain or common public. So basically, if you will see these motorcycles, you can easily check out that different manufacturers, they make different components for these motorcycles. For example, if you will check motorcycles, simply you go and check the tires. Simply go and check the tires, you will notice that those tires are not made by Hero Motor Corp. Generally, in a motorcycle, the tires are provided by either MRF or Seat. Basically, these are the companies that make motorcycle tires. Okay, so all I am saying is that different products are manufactured by different companies, and what Hero Motor Corp does, that yes, they definitely manufacture some of the major components inside the Hero Motor Corp factory only. I mean, like the engine, the chassis. The chassis is like the entire frame on which the motorcycle engine gets mounted, the gearbox. So the major components are definitely made by Hero Motor Corp only, but there are so many different small equipments that need other manufacturers to get involved so that Hero Motor Corp can create a complete product like Passion and can sell it in the market. Okay, so basically what happens that inside the Hero Motor Corp factory, you can find an assembly line. On an assembly line, what happens is that the entire assembly process of the Hero Passion motorcycle will start at say this point. Let me mark this point as red. This is the point where the entire अंकुर is saying, sir, notes नहीं मिल रहे आपके ग्रुप में. Ankur, I will be sharing the notes once I have completed the entire topic. I have said this again and again, and I will say this one more time. I will only be sharing my notes on the Telegram channel once the entire chapter is completed. So I completed forecasting the last class, the previous class. I will be sharing the notes of forecasting today, and when I will complete line balancing, then I will share the notes of line balancing. And I think before forecasting, every topic that I have taken, I have shared its notes on Telegram channel. Okay, guys, please now let us move on. So I am saying that just consider this red mark where the assembly process of a Hero motorcycle starts. Now what would happen at this particular point? Some worker some worker who is at workstation 1, okay, some worker who is at workstation 1, what this worker will do, there will be some sort of shelves or some sort of racks kept behind the workstation 1 where there will be all kinds of parts available, kept ready with all marked barcodes and everything, so that this workstation 1 worker can take up that part and can put it on the assembly line. So basically, let's say when the motorcycle assembly process starts, the first thing that we need is the chassis of the motorcycle, the frame of the motorcycle. You must have seen whenever we take out the tank from the motorcycle, from the bike, you see a sort of pipe going. Okay, the bicycle that we ride, it also has a frame, a similar sort of frame which we call as a tubular frame. It is available on the motorcycle also. Okay, basically it holds the entire motorcycle together. The frame is that part which holds the entire motorcycle together. Whether it is the engine, it is the gearbox, it is the tires, brakes, anything. Everything is mounted on the chassis, on the frame. So what the worker does, the worker who is at the workstation 1, when the assembly line starts, he take out one chassis from the shelf and keep it on the assembly line. And then there is an entire system, okay, then there is an entire system like an ERP system. And what he basically does, that if you would have seen a motorcycle, if you have seen a motorcycle very clearly, you would know that on the motorcycle there is a chassis number. Whenever you have bought a motorcycle, what they do, they use a piece of paper and a pencil and keep it on the frame where that number is engraved, and then by keeping that paper on the engraved number, they use the pencil, and in that way the impressions came upon. Okay, sir, why the frame is circular section? Is it good for arresting vibrations? Ashwin, to be very honest, I don't know. Now, listen to me, what I am saying, okay? So all I am saying is that the motorcycle that we were talking about, where was I? Ashwin, you completely got me. Your question tumbled me and now I can't remember where was I on my... Okay, so I said that the workstation 1 worker, what he will basically do, he will put the chassis and he will keep it on the assembly line. And now, in the system, in the computer nearby, he will make an entry that this chassis number is being used for this particular product or this particular motorcycle. Then in the entire system, that entry gets recorded. So whomsoever is responsible for fulfilling the shelves near the workstation 1, whomsoever, no need to say sorry Ashwin, no need to say sorry, okay. Sangram is saying nice question, very nice question actually. Why the frame is in circular section, I will definitely try to gather more knowledge about this, because I never ever thought about it. It must be something related to the concept of strength of material, but currently I cannot relate things. Okay, so now let me just focus on to this. Now, this system that I am talking about, basically when a worker uses a chassis from the nearby shelves or racks. Now, if he choose one chassis and he makes the entry on the system that this particular chassis with this particular chassis number is being used for a product motorcycle, this, and that entry basically is available at an instant to everybody who needs that particular data in order to do his or her job properly. Suppose there is someone who is responsible in order to fill those shelves with products or fill those shelves with equipments, so that the workstation 1 worker will always have products nearby him in the shelves, so that he can pick up those products and simply put it on the assembly line and start the assembly process. Okay, so now what happens, that he puts the chassis on the assembly line, and now what he do, he take up an engine and start bolting the engine on the chassis. Now meanwhile, when he does this job, the duration in which he is doing this job, this assembly line is basically moving. Okay, so assembly line is basically moving with a very slow speed, let's say, but yes, it is moving, and the duration in which this assembly line moves from this point to this point, that is from the starting of the workstation 1 up until the end of the workstation 2, this duration is set in such a way, the speed of the assembly line is adjusted in such a way that whatever the time is required by the worker on the workstation 1 in order to put up a chassis, make the entry, then bolt an engine, the entire duration that is required by the worker at the workstation 1 to perform this job, or whether there is a machine at the workstation 1 which is performing this job, whatever time is required by that machine or by that worker, the assembly line will be moving in that particular time from this point to this point. Now you will ask me, sir, how can we know that what time is required? For that, guys, we will study work study. Okay, work study is basically that chapter which will help us to find out that what is the standard time or what is the time required to do a particular job which is being assigned to us. They deal with all kinds of method study and time study techniques in which we study each and every way to do that job, possible way to do the job, and we find the best possible method to do that job, and we train the entire working staff so that everybody is capable of doing the job in a given time frame. Okay, so that is how this time is being calculated. Now similarly in on workstation 2 there will be some other jobs that will be going on that assembly process of the motorcycle. Somebody on the workstation 2 will be putting the tires, somebody will be putting the brakes, somebody will be putting the handle. So on different workstation everybody will be doing their own job, and in that time period the assembly line will be moving from one point to the other. The assembly line will be moving, will be keep on shifting from one point to the other, and in this way when the assembly line will complete one complete cycle, that it has started from, let's say, workstation 1 and the complete movement up to the workstation 3 happens, then I will say that all the jobs that were required for the complete assembly of the particular motorcycle, that jobs are completed, and I can say at the exit of the workstation 3 we can have a finished assembled motorcycle which is ready for testing, loading on the truck, going in the market and getting to in the hands of a able customer. Now let me read your comments. Circular section might be used because of more section modulus concept which you can use there. Hey Ashwin, circular section is used. Everybody is trying to be me. Everybody is trying to answer and increase the bending strength. Sanjay is saying normal time plus allowance is equal to standard time. Yes, Sanjay, that is one of the concepts of work study. We will be dealing with that in the upcoming classes. Guys, literally, I do not know the answer of the question Ashwin has asked. There can be several reasons, not one, not two. Okay, I think the reason that Rajan Soni is providing that circular section might be useful because more section modulus, that could be the reason, but I am not really sure, so I don't think I should be answering it. Okay, because you see, guys, whatever I will say on this YouTube channel, okay, I mean it is not only live, it is going to be there on this channel, let's say, forever. So whatever I will say, if I am not 100% sure about that, I cannot say like this. It's not like just to give somebody some answer or to just satisfy my ego to provide you with a proper answer because somebody has asked a question. I just simply cannot say that कि यार ये ऐसा होता होगा, this might be the case, because if I would say so, this is going to be on YouTube forever, and I don't think that a mere ego satisfaction example or a mere ego satisfaction sentence would hamper somebody's ability to study on YouTube or on any other platform. Actually, in my opinion, sharp edges are not there in circular, so the failure rate is low. Ashwin, why are you saying sorry, man? Why are you saying sorry? I'm not blaming you. Okay, I am not at all blaming you. You have asked a good question. No need to worry. So guys, let us proceed then. So all I am saying is that from this particular point to this particular point, the total time, let's say required is TC. So TC is basically called as the cycle time. Sorry. This buggy software. So okay. So guys, let me proceed, 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 let me proceed. So now I think you all might have understood what is an assembly line. Basically, assembly line is a moving line, is a moving belt on which along the moving belt, there are workstation installed or established, and on those workstations there are machines or man who are continuously working on the best of their abilities so that the entire assembly process can be completed in a provided standard time, in an estimated standard time. Every job gets completed how it is supposed to be completed and within a given time period that is being decided or is being estimated by the researchers who are actually developing these methods. Okay, in that estimated time we complete the assembly of an entire motorcycle. So guys, now let me just move on, guys. Do you know who introduced the concept of assembly line? Who was the person who introduced the concept of assembly line? Have you ever heard the name Henry Ford? I mean, most of you might have, if you are into cars or if you are into mechanical engineering, then most of you might have heard this name Henry Ford. Henry Ford was the founder of Ford Motor Company, and he was that man, he was that fellow who was responsible for the world's first public car that was named as Model T. Okay, in the year 1905, 10 years before the First World War, Henry Ford was the person who introduced the world the concept of a passenger car. I mean, he was not the founder of cars or he was not the first one ever to make a car. Okay, it was Carl Benz who was, I think, somewhere in the 1800s developed the first automobile or the first car. Okay, but Henry Ford was the first person who commercialized it, who started manufacturing these cars on a large scale so that it can be available to the common public and they can use it. Okay, so Model T was that car. So what happened when Henry Ford introduced Model T, it instantly became a hit. It instantly became a hit. I mean, everybody want that car. It was small, it was affordable, it was a dream come true for a human being, so that everybody dreamt about riding a vehicle at that time, and Henry Ford made that dream come true. So Model T was an instant hit, was a very successful product by Ford Motors. So what happened that the demand for Model T was such a huge success that Ford company, they had set up a factory in order to produce Model T, but the production capacity was just not enough and they were not able to meet the demands of the customers. Now, in order to take care for that, Henry Ford did set up one further company. But then also the demand skyrocketed in the whole of America and they were just simply unable to deliver to the customers. They were just simply unable to fulfill the demands. So what Henry Ford did at that time, he decided that whatever facility I have, whatever resource I have to make the best out of it. Basically, Henry Ford applied operations research. Okay, Henry Ford applied operations research. This concept of assembly line was introduced by Henry Ford himself. Henry Ford designed the entire assembly line process. Why he did so? Because at that time, I don't know how was the manufacturing process was going at that time, but I just imagine that you must have visited those mechanic shops in India where if somebody is working on a motorcycle, he must be asking the other guy, hey, pana lana, hey bhai spare lana, hey bhai sparrow lana, jo bhi lana. I mean, they keep on ordering somebody, just give me that, just give me this, and everybody is running from here and there. Chotu is running from here and there and getting the searching the parts and everything so that this main mechanic can assemble the motorcycle. So I can imagine how things were cluttered at that time. And Henry Ford, all he did, he made that entire manufacturing process lean. People are continuously asking me, sir, what is lean manufacturing? Guys, lean manufacturing. When I use the word lean, it simply means कि when I say that somebody has a very lean body, it means that he has very less waste, he has very less unnecessary things over his body. Okay, whether it is fat or whether it is muscle or whatever it may be, but lean body simply means that a body which has very less unnecessary weight, unnecessary mass. So lean manufacturing simply means when we just smoothen out the manufacturing process, when we eliminate the inefficiencies, when we remove the waste, when we throw away the things that are unnecessary, okay, and makes the manufacturing process very smooth, very light and very efficient. That is what lean manufacturing is. So basically what Henry Ford did, he made the assembly line process in such a way that he somehow made it organized, made it efficient, and he was somehow managing to increase the productivity by utilizing the resources that he already has. Okay, so he was the person who introduced the concept of assembly line. Now let us straight away get into this. Let us just straight away get into the part where I should be discussing some concepts. Suppose there are three workstations. Suppose there are three workstations. Let's say there is workstation 1, workstation 2, workstation 3. So let's say on workstation 1, it takes 2 minutes time to complete the job. Whatever job has been assigned at workstation 1, it takes 2 minutes in order to complete this job. Similarly, let's say on workstation 2, it takes 4 minutes time. And on workstation 3, it takes 3 minutes time. So 2 minutes, 4 minutes, 3 minutes are the respective durations required at workstation 1, 2 and 3. Now let's say I take a stopwatch and I start the assembly line process. I start the assembly process and at the same time I start the stopwatch. Now let's say the product or the motorcycle entered the workstation 1, the stopwatch showing 0. Now as soon as it will exit the workstation 1, the stopwatch will be showing 2 minutes because 2 minutes have gone by. Now remember, this workstation 1 and 2 might be different, but the assembly line on which the machine or the motorcycle has been kept, that is constantly moving. So as soon as the assembly line exits workstation 1, it has already entered workstation 2. They are not separate. Okay. So now I am saying that the duration between workstation 1 and 2, the duration within which the motorcycle can reach from workstation 1 to workstation 2 is negligible, because the motorcycle is already there. If it has exited workstation 1, it has entered workstation 2. So started at 0, ended at 2. Now it will enter the workstation 2 at 2 minutes, and after 4 minutes, that is at 6 minutes, it will exit. Again it will enter the workstation 3 at 6 minutes, and it will exit the workstation 3 at 9 minutes. I hope up until this point everything is clear to each and every one of you, and if you have any doubt, just write it in the comment box so that I can deal with that. Okay. Now after 9 minutes, after 9 minutes, we will get the first motorcycle. We will get the first motorcycle. Now, if I will ask you that on the 9th minute you got the first motorcycle, then at what indication on the stopwatch, at what time on the stopwatch we will be getting the second motorcycle? The question is, at what time on the stopwatch you will be getting the second motorcycle? Just answer this question and then I will move on. Just answer this question, then I will move on. Just answer this question, then I will move on. After 9 minutes we are getting the first motorcycle. Then after how many minutes I will be getting the second motorcycle? Or at what time I will be getting the second motorcycle? Guys, come on. Let me just tell you this. Ashwin is saying 18 minutes. Anybody else have any answer? Anybody else have a different answer? Ashwin, 18 minutes is the wrong answer. 18 minutes is the wrong answer. 9 minutes also is the wrong answer. Just check this out, guys. Just check this out. You see what will happen? That the workstation 1, this workstation here, this workstation requires 2 minutes time. This workstation requires 2 minutes time to complete the job. And as soon as the motorcycle exited from workstation 1, that is on 2 minutes, on the very second minute I can enter the second motorcycle. I can start assembling the second motorcycle on the second minute without wasting any more time. Then if the second motorcycle has started the job on the second minute, then 2 plus 2 will become 4. Then this motorcycle, at what time it will enter here? Hello guys, come on, tell me. Okay, Kishore, just tell me that if the motorcycle, the second motorcycle, this was the first motorcycle, let's say this is the second motorcycle. The second motorcycle started the job on 2, ended it on 4. At what time the second motorcycle will enter the workstation 2? Yes, Kishore, exactly. Kishore is right. It will enter on the 6th minute. Although, guys, please check this out. Let me just red mark this. Although the job was completed on the 4th minute, but the second motorcycle entered the workstation 2 on the 6th minute, and here there was a delay of 2 minutes. The motorcycle had to wait. The product had to wait. Now this product will exit at the 10th minute. 6 plus 4 is 10. And remember guys, the workstation 3 is already vacant on the 9th minute. There is nothing going on the workstation 3 after the 9th minute, but because the motorcycle will exit the workstation 2 on the 10th minute, I will have to enter it on the workstation 3 on the 10th minute, not on the 9th minute, and then 10 plus 3 will become 13. So guys, again you can clearly see that this machine was free on the 9th minute but got the job on the 10th minute. So here I can say there is 1 minute delay, or there is 1 minute idle time for the machine 3, or idle time at the workstation 3, whether it is being done by a man or by a machine. Remember guys, here in between 4 and 6, the 2 minutes delay is with respect to the motorcycle. The motorcycle had to wait because the machine was busy, and now in this case the motorcycle was busy and the machine was waiting. So in both the cases guys, we have lost some time. Let me just mark this. In both these cases guys, we have lost some time, which if we would have utilized, this time, then the productivity would have increased. I would have made more products in that particular time, because if I would not have wasted that time, I would have utilized it in the assembly process. So guys, let me just move on. Let me take the case of the third motorcycle. The third motorcycle will enter on the 4th minute, exit on the 6th minute, but will enter on the 10th minute, because up until the 10th minute the machine 2, the workstation 2 is busy. Then remember guys, after 10 it will exit on 14. This machine is already free on 13, but the job is delayed, so it will enter on 14 and it will exit on, did I made some mistake? 17th minute. How 1 minute in 10? Sanjay is asking, sir, how 1 minute and 10? Sanjay, please listen to this carefully. This workstation 3, it has completed its job on the 9th minute. But then the second job, it entered the workstation 3 on the 10th minute. That shows that it was free on the 9th but got the job on the 10th. So there is a 1 minute waste or 1 minute idle time for this workstation 3. Guys, let me just rest my voice for a second. I just need to take a sip of water. So, let us move on. So now guys, why I did all this? I just wanted to tell you that except for the very first motorcycle, keep aside the first motorcycle, after every 4 minutes of time, we will be obtaining one motorcycle. After every 4 minutes of time, we will be obtaining one motorcycle. That means after 71, I will get the next motorcycle on the 21st minute. Then it will be on the 21st, 5th minute, and then it will be on the 29th minute, and so on. So basically, after every 4 minutes, I will be getting another motorcycle. Sir, for third on W1 to W2, it's 4 minutes or 2 minutes. It will be 4 minutes, Ashwin, because the workstation 1 will get free on the 4th minute. So the job will enter on the 4th minute. Okay. Now listen guys, listen to me. All I have explained up until now is that we will be getting a motorcycle on every 4th minute. So guys, what is basically happening is that after every fourth minute, let me just write this down. After every four minutes, one cycle is completed. What is this cycle? Guys, this cycle simply means that we started from the workstation 1 and we ended on the workstation 3. So basically, the start of the assembly process up until to the end of the assembly process, I am saying that is one cycle, and in every 4 minutes one cycle is getting completed, and after every 4 minutes I am getting one motorcycle. Okay, so this 4 minutes is called as the cycle time. The time in which one cycle gets completed is called as the cycle time. And now if you will check this out, you will find that this cycle time is identical exactly identical to the time which is highest among all the workstation. If you will check this cycle time is exactly identical to the time which is maximum of all the workstations. So guys, simply understand this, whether you have 5 workstation, 50 workstation or 50,000 workstations, whatever be the duration which is going to be the maximum duration with respect to any workstation of all the workstations, that is going to be the cycle time, and that is going to be that time in which you will be getting one product, one complete assembled product. Okay, so cycle time is basically the highest time out of all the machines. Now let me just take the explanation part even further. Now guys, if I will try to find the average time on a workstation, as on work as these products or the motorcycle is spending 2 minutes on the workstation 1, 4 minutes on the workstation 2, 3 minutes on the workstation 3, at every other workstation they are basically spending different amount of time. So let's say I want to find the average time spent by a product, a motorcycle on any workstation. What I will do, I will simply add up all the times of the workstations and just simply average it. So this will give me 3 minutes. This will give me 3 minutes. Now think this very hard, think about this very hard. Let's say if the average time spent on any workstation is just 3 minutes, then guys, then the thing is that if every workstation get an average time of 3 minutes, then the cycle time will also be equal to 3 minutes. If the average time at any workstation is 3 minutes, then I am saying that after every 3 minutes time I should be getting one motorcycle. But the thing is, I am getting a motorcycle after every 4 minutes. So a job which can be done in 3 minutes time, a motorcycle which we can obtain in 3 minutes time, basically we are obtaining the very same motorcycle in the 4 minutes time. And why this is happening, guys? This is all happening because of this green box, the box that I am ticking right now. It is all happening because of these inefficiencies. Let me just call them inefficiencies. We have the workstation, we have the job, but then also these little inefficiencies are there, these little delays are there, whether it is with respect to the machine or with respect to the job. But due to these inefficiencies, a job which can be done in 3 minutes time, in 3 minutes time I can get a product, but I am getting the product at after 4 minutes. Behind every single job I am losing 1 minute of time. Behind every single job I am losing 1 minute of time, or I can say that in one cycle time, after every 4 minutes I am basically losing a single machine, a single motorcycle. That is the level of this inefficiency. Now, let me just move on. There is a term called line efficiency. There is a term called as line efficiency. What line efficiency is? It is given by average time to that of cycle time. And as we have checked in this case that the average time is 3 minutes and the cycle time is 4 minutes, that gives me 0.75. So basically this relation tells me that this particular assembly line, Arunopal is saying, sir, that 1 minute inefficiency I am not getting. Arunopal, please focus. Okay, please focus this time. Arunopal, the first motorcycle, it exited from the workstation 3 on the 9th minute. That means on the 9th minute, the workstation 3 was free. But the job, it entered this workstation on the 10th minute. That means this setup, this workstation 3, this facility had to remain idle for 1 minute time. Similarly, you can see this here. The motorcycle number second exited the workstation 3 on the 13th minute, but the workstation 3 got the next job on the 14th minute. So again, there is a delay of 1 minute. That means the workstation 3 had to remain idle for 1 minute. So all I am saying, guys, whether the setup remained idle or the job had to wait because the machine is busy, all that is inefficiency in the system. Whether the machine is remaining idle or the job is waiting for the machine to complete its job, in both situations we are losing time. We have the capacity, we have the setup, we have the potential, but just because the working has not been organized properly, the setup has not been organized properly, we are losing time. Those are basically the inefficiencies. And now I have told you how to calculate the efficiency of a line. It can simply be calculated by calculating the average time per station divided by the cycle time, which in this case is 3 and 4. So from here I have calculated that this assembly line that I have provided you with 2 minutes on workstation 1, 4 minutes on workstation 2, 3 minutes on workstation 3, this assembly line is only 75% efficient. That means if there are 100 minutes in the production system, then only 75 minutes of the time production process is happening. The rest 25 minutes, it is complete wastage. Complete wastage due to the inefficiency of the system. All I can say, if this line is 75% efficient, then there is a 25% inefficiency in this particular assembly line. So guys, I hope now the concept of line efficiency is clear to you. What is line efficiency? But remember, we are not studying line efficiency, we are studying line balancing. Now guys, just get on to this so that I can explain further. Guys, this line efficiency has told us that this particular assembly line is only 75% efficient and there is a 25% inefficiency. Or we can also say that there is a 25% imbalance in the system which needs to be balanced. Now I ask you the very same question. Now I ask you all the very same question. Let me just mark this. Let me just draw this for you. Now guys, listen to me. My objective is to eliminate this 25% imbalance, or my objective is to balance this assembly line. My objective is to balance this. By balancing this, I simply want to remove these delays or these waiting intervals, inefficiencies. I want to make sure that the entire assembly line process becomes smooth flowing. There should not be any blockage. No job has to wait before a certain workstation. The line should never stop. The machine, the line, the assembly should keep on moving at all times. There should not be any blockage, any stoppage, because either the workstation is busy or the job is busy on some previous workstation. So whatever may be the case, whether it is the delay of 2 minutes in this case or a delay of 1 minute in this case, I want to eliminate this delay. Completely eliminate this delay. My question to you guys is, how can I do that? How can I achieve that? What should I do? What should I do in order to make this line 100% efficient? In order to achieve the very same average time and cycle time, because when the average time and cycle time will be same, then only I can say the line is 100% efficient. There is no sort of delay, no sort of imbalance. So what should I do? What should I do in this case? In the case of these three workstation, what should I be doing in order to obtain the line efficiency of 100%? Come on, please guide me. Please tell me what should we do. It is simply a question of aptitude. Come on, guys. You all are studying aptitude. You all are investing your time, energy on studying aptitude. I want all of you. Ashwin is saying, sir, replace W2 and W3. Ashwin, remember, what you are asking currently is not possible at all. Okay, because remember, Ashwin, the workstations are set up as per the chronological order of the work on the workstations or on the assembly line. Suppose on the workstation 2, one's job is to put tires on the motorcycle, and then on workstation 3 somebody will put brakes on those tires. So if I will swap the two workstation, then on workstation 3 somebody will be putting brakes and then somebody will be putting tires on the workstation 2. That will not be the case. So we cannot swap workstations. Fundu and Fact channel is saying, sir, increase the workstations. Increase the workstations. Increase the workstation. Fundu and Fact, can you be more specific? Can you be more specific? Come on, tell me. I get the point that you are asking me to simply increase the workstation, but should I be increasing the workstation like from W1, W2, W3 to another workstation like W4? That is what you are asking me to do. Or you are asking me to add more workstation on the workstation 2. Make 2 workstation 2 or 3 workstation 3. That is what you are asking, or you are asking me to add a workstation 4 here. Come on, be more specific. Be more specific. Be more specific. Hello guys, can I get a response? See, chaliye, let's just simply focus. Can we break the second workstation into 2 workstation? Sir, please repeat question. Increase workstation 2, sir. Sanjay is asking me to repeat the question. Sanjay, I am saying, my man, that I want to remove the inefficiency. I want to make this line 100% efficient. That means I want to make sure that the average time and the cycle times are equal. Then only I can have 100% efficiency. What should I do to remove this kind of efficiency? So guys, let me just explain this to you. Let me just explain this to you. What we should be doing. Okay, guys, the method that I will be telling you here, you might not find this method on any textbook or anywhere else. So please just concentrate. It is very simple. Nothing new about this. If you will use your mind, you can simply extract the answer by looking at the values. You won't even have to do the steps that I will be doing. Okay. So do one thing. Just write the station times here. 243. Now out of all these station times, select the one which is the least, that is 2. 2 is the least. Simply divide 2 across all the workstation times. Simply divide 2 across all the workstation times. Now I will get 1 here, 2 here, 3 by 2 here. Then see, if there is some fractional value left, if it is integers, if all the values are integers, then there is no need to do anything else. You can just simply stop there. But if there is some fraction, you just have to convert this fraction into an integer. That means simply multiplying all the other values by 2. So I get 2 here, 4 here, 3 here. These are, just let me write this, just let me write these. I cannot draw a straight line. These are number of machines required on respective workstations. So guys, what these three values simply tells us, that make 2 workstations 1, make 4 workstation 2, and make 3 workstation 3. Try to understand what I am saying. Okay, it is simply saying that if I can place 2 parallel workstation 1, rather than setting a workstation 1 here on their own, if I can set up a workstation 1 here also, 2 workstation along the assembly line. Simply it is saying just make 4 workstation along the workstation 2, make 3 workstation along the workstation 3, or you can simply think it like this: on the workstation 1 make sure there are 2 workers, on the workstation 2 make sure there are 4 workers, and on the workstation 3 make sure that there are 3 workers. Now you know what will happen if I will do that. If on workstation 1 I have a job which requires 2 minutes of time, if on workstation 2 I have a job which requires 4 minutes of time, and if on workstation 3 I have a job which requires 3 minutes of time, then if I will place 2 workers on this very workstation, if I will place 2 workers on this very workstation, then what will happen to these 2 minutes, guys? Please write in the comment box. If this job is being done by a worker in 2 minutes, and if I will make sure that there are 2 workers now on this very workstation, what will happen to these 2 minutes? What will happen to the duration of that job if 2 men are doing the same job? Gopal Krishna Vasantha is saying it will become 1 minute. Guys, will it? Will it become 1 minute? No, my friends, no. Never ever make that mistake. Never ever make that mistake. Okay? Never ever make that mistake. No, Gopal, just listen to me. Guys, just concentrate on my words. When I say that this job requires 2 minutes time, then whomsoever is doing this job is trained in such a way that he or she is performing the job in the required studied time. The time that is being standardized to do that job is 2 minutes. It's not like building a wall. It is an assembly process. And in this assembly process, there are no two machines, no two man that can do this job. This is a one man job, one machine job. We are assembling the product, not manufacturing a wall or not constructing a wall. Where if I will keep two laborers, then the job will get done in minimum duration or less duration. No, that is not the case. This is an assembly process, guys, and in this assembly process, when I say a job required 2 minutes time, then basically I am indicating that whether I will be appointing a man or a machine, it will take 2 minutes time to do the job. Now remember, if I am adding two men to do this job, if I am adding two machines to do this job, you know what will happen? In 2 minutes time, not one, but two jobs will get finished. If I will add two machines here, if I will make the workstation 1 into two workstation 1, if I will add two men here, two machine here, then in this very 2 minutes duration, not one but two jobs will get completed, because two men are doing the job for 2 minutes. That means a total of 4 work minutes, work hours, work minutes. Total 4 work minutes are getting invested in this workstation, and in those 4 minutes, in those total 4 minutes of man hours, I can say that two jobs will get completed. So guys, now I hope that this is clear to you. Now I hope that it is clear to you that in 2 minutes time I will get two jobs. So I can say that on an average, from this workstation 1, on an average, remember I am not saying the job is getting completed in 1 minute time. I am saying on an average, 1 minute, one job. Although 2 minutes are being taken by a single job, but in the 2 minutes time, I will not be completing one job but two jobs. So I can say that in an average of 1 minute, an average one job is completed. Similarly, guys, if I will put 4 machines here, so in 4 minutes time, not one but 4 jobs will get completed. So again, I can say on an average, one job in 1 minute. And on workstation 3 also, I can say the very same thing, that on an average, one job in 1 minute. So guys, basically what I am saying is, if I will put two machines here, if I will put 4 machines here, 3 machines here, then the the station time will get reduced to 1 minute. In terms of average station time, here it will also be reduced to 1 minute. Here it will also be reduced to 1 minute, 1 minute, 1 minute. And guys, now you can see, if I will add all these values, 1 plus 1 plus 1 by 3, I will get 1 minute as the average time. And the cycle time is the highest of the lot. The highest of the lot is also 1 minute, so the cycle time is also 1 minute. So the line efficiency that I talked about will be 1 by 1, which is equal to 100%. Is it clear to each and every one of you? Is it clear to each and every one of you? Is it clear to each and every one of you? I hope it is. Guys, simply remember, just select the minimum time of all the workstation, divide it by all the other station times, and simply make sure that no values remain in fraction. Whatever number you achieve, that number should get multiplied on the workstation. Simply you have to make sure that those are the number of man and the machines that should be there on this workstation in order to make this line assembly 100% efficient. Is it clear, guys? Guys, is this clear? Is this clear? If it is, let me take one more example. Let me take one more example so that I can cross verify whether you guys understood the concept that I just gave you. What I understood, I would like to check that whether you guys get my point or not. So let's say there are 9 minutes on the workstation 1. On the workstation 2, there is 12 minutes. On the workstation 3, there is 15 minutes. And on the workstation 4, there is another workstation 4 which has 21 minutes. So the question is, guys, the question is number 1, what is the efficiency? What is the efficiency of this assembly line? And second question, what to do to make this line 100% efficient? So guys, I will be resting my voice for 15, 20, 30 seconds. Just go there with lightning speed. If you have developed the concept, just go out there with lightning speed and solve this question within no time and just give me the answer in the comment box. Come on, straight away. I'm waiting for your answers. Come on, guys. I'm waiting for your answers. The first question is asked that what is the efficiency of this line? So this simply means P average by TC. So P average will be 9 plus 12 plus 15 plus 21 by 4, and the cycle time will be the highest, that is 21. Where is my good old calculator? It is here. So let me just calculate this as well. 9 plus 12 plus 15 plus 21 by 4 divided by 21. So this is turning out as, what are the values that you guys are getting? Mine is coming out as 67.8. So very nice, Arunopal and Fundu and Fact. 67.85%. This is the line efficiency that we are getting. And we have to make this line 100% efficient. And for that, we have to find that how many machines we should be putting on these workstation in order to make this line 100% efficient. 9, 12, 15, 21. Dividing all the durations by the least time, that is 9, I'll get 1, 4 by 3, 5 by 3, 7 by 3, multiplying the values by 3, multiplying the values by 3, I will be getting 3, 12, 15, 21. 4, 5 and 7. Arunopal, your answer is wrong. Your answer is wrong. I need 3 machines here, 4 here, 5 here and 7 machines here. Remember, you just have to make sure that no values remain in fraction, and in order to convert these values, I just need to multiply them by 3. So this becomes 3, this becomes 4, 5 and 7. So these are the machines that I require on all these workstations. If I will do that, the average time on this workstation will become 3 minutes. Again, the average time here will become 3 minutes. Here also it will become 3 minutes, and here also this will become 3 minutes. So guys, if you will do this, all the station times will become 3 minutes, the cycle time will become 3 minutes, and remember, the efficiency of the line will become 100%. There is one more aspect to this question, guys. There is one more beautiful aspect to this question, which I think you guys are missing and I haven't told you guys yet. So what I will be doing, I will be giving you guys one question. I will be giving you guys one question, and with the help of that question, let me try to explain. That beautiful concept to you guys. Okay, so let me just write down that question. It is required to produce 800 units of a product, 800 units of a product in a 8-hour shift, full stop. A unit requires operation on 3 machines, M1, M2 and M3, full stop. The processing time per machine is 6 minutes, comma 18 minutes and 15 minutes respectively. Determine number of machines M1, M2 and M3 are required. So guys, this is the question. Sir, in reality, it can be possible to achieve 100% efficiency in assembly line. Yes, Amit Ranjan, it can be done. It can be done. I am not saying that it will be the case for a very long time or for a very long duration, but yes, for a short amount of run, for a short production run, you can achieve. Thank you so much for teaching in English. Very helpful. Once again, thanks, sir. No issues, Banu Rajan. I try to be teaching in English only because I have seen that there are students from South also who are indulging in GATE and ESE preparations, and they are having language issues when teachers are teaching in Hindi. So I will try to take these lectures in English only because English is that language which I think that students from north, east, west, or whatever parts of India, they can now opt for that, because remember, GATE is quite an examination, and in GATE examination also English is a necessary language. So guys, I think we all should make sure that we know English. Okay, okay, okay. So guys, this is the question in front of your screen. Please start solving this question. Please start solving this question. Yes, guys, just by simply going by your names, I can tell that you guys are from South. Okay, Gopal, very nice. Guys, just solve this question. Let me just check the time. It's already 10:38. I mean, YouTube kills, man. I don't know where time passes by on YouTube. Even on the Unacademy special class, I think that in 1 hour I teach a lot, but I don't know what happens on YouTube. Somehow time just slips. So has anyone solved this question? Has anyone yet solved this question? Guys, I won't be solving this question unless and until I get some answers in the comment box. I want answers from you guys. No, Arunopal, no, no, no. Please go through the question properly. Please go through the question properly. Don't be in a hurry to answer. Please read the full question. Please read the full question. I have added some things in the question. No, Ashwin, no, guys, please. Please, your answers are killing me, guys. Your answers are killing me. Please read the question properly. Don't be in a hurry to answer the question. Whatever may be the situation, whether you are in the examination hall, whatever may be the case, never ever get excited before solving a question. I know this is a very easy concept, and you people might be thinking, oh my god, what an easy question. No, Harsh, this is not M jobs and machine. That is in sequencing model. I think the classes of sequencing are scheduled for tomorrow. I think tomorrow I have to start sequencing model on YouTube. No, हर्ष ये वो वाला केस नहीं है. This is a question of line balancing. Come on guys, come on. चलो यार, just I think I will have to answer. Let me just deal with this. Let me just deal with this question. Guys, now there are three machines having times of 16, 18 and 15. If I divide the least time with all the other durations, I'll get 1, 3 And what will this be? 3 to the 6, 5 by 2. I'll just have to make sure that I make every value in an integer. So this gets multiplied by 2 becomes 2, this will become 6, this will become 10. This will become 10. So these are the number of machines. So here I will have to add 2 machines. Here I will have to add 6. Here I will have to add 10. If I will do that, if I will add 2 machines here, earlier these machines were doing the job in 6 minutes. Now as there are 2 machines, this job will get done in 3 minutes time. Similarly, earlier this machine was taking 18 minutes time. Now 6 machines are there in parallel. So the average time will be 3 minutes. Again, the average time in this case will also be 3 minutes. So basically guys, now what happens? The average time is also 3 minutes. The cycle time is also 3 minutes. So 3 by 3 is 1. The cycle is 100% efficient. That we have made sure that the cycle is 100% efficient. Listen to me guys, listen to me properly. Okay, just focus on the screen. Ears on my voice. Now the thing is that the cycle time is 3 minutes. That means every 3 minutes, I am producing one product. Every 3 minutes. If the cycle time is 3 minutes, that means on every third minute I am getting one product. On every 3 minutes, I am getting one product. Sanjay is asking me to repeat. Sanjay, I should repeat what? The point that I just told or the entire solution? Sanjay, the entire solution or the first point that I have just told? What I have just told is that the average time on each station has become 3 minutes. That means the cycle time is also 3 minutes. So if the cycle time is 3 minutes, I am producing one product in every 3 minutes. Currently, the manufacturing capacity is such that in every 3 minutes, let me just write this properly. In every 3 minutes, I will get 1 unit. I will get 1 unit in 3 minutes. But guys, check this out. How fast 3 minutes you calculate? Sanjay, I calculated 3 minutes like this, that currently the times are 6 minutes, 18 minutes and 15 minutes. I have found that I need 2 machines here, 6 machines here, 10 machines here. Now 6 by 2 is 3, 18 by 6 is 3. This one is 15 minutes. Sorry, I wrote 10 here, this will be 5. I am really sorry guys. I did not pay attention here. I am really sorry. This is 5 and there are 5 machines here. Okay. 5 machines here. So 5 3s are 15. So guys, listen to me. I am saying that in every 3 minutes I am getting 1 unit. But remember, I need 800 units in a 8-hour shift. I need 800 units in an 8-hour shift. 8 hour is how many minutes? 480 minutes. So I need 800 units in 480 minutes. That means if I will calculate it, I will need 5 by 3 units. 5 by 3 units every minute. Guys, are you guys focusing on what I am explaining? I am saying that if I need 800 units in 480 minutes, then basically I need 5 by 3 units in 1 minute. Simply I did 800 by 480, I am getting 5 by 3 units in 1 minute. So I want 5 by 3 units in 1 minute, but I am getting 1 unit in 3 minutes. I am getting 1 unit in 3 minutes. So if I will just reciprocal this, let me just use the eraser to explain this to you guys. If I am getting 1 unit in 3 minutes, I can write that in 1 minute's time I am getting 1 by 3 unit. And remember, I want 5 by 3 units in 1 minute. That means whatever the facility I have, if I am getting 1 by 3 units in 1 minute and I want 5 by 3 units in 1 minute time, that means I will have to multiply the manufacturing facility by 5. I will have to make sure there are 5 facilities like this, 5 times facilities like this. That means, guys, I am simply multiplying these machines by 5, then only I can have 5 times more capacity. That will make these values 10, 30, 25. So guys, if I will have 10, 30 and 25 machines, that will be basically the multiples of 2, 6 and 5. Then 10, 30, 25 will make sure that I have 100% efficiency, as well as I can deliver 800 units in an 8-hour shift. That is, in 480 minutes time, 800 units will get shipped also, manufactured also, and the line will remain 100% efficient. I hope this question is clear to you. If you guys have any doubt, just write it in the comment box, because time is very less here and now we just have to say goodbye to each other in a moment. So please guys, if you have any doubt, just write it in the comment box so that I can simply deal with it right away without wasting any more time. First, we made the line efficient. So we obtained 2, 6 and 5 number of machines. So Kishore is saying that it is clear to him. Arunopal is saying it is clear. What about others? What about others? Come on guys, come on. Gopal's concept is cleared. Sanjay is saying Anand aa gaya. Very nice Sanjay, very nice of you to say these words. Others, come on guys, don't feel shy, just comment, comment. Anything is there. Sir, can you say again? John Finjo Raji is asking, sir, can you say clear? Sir, now I know where I did make a silly mistake. Okay, John, just listen to this. I had 3 different machines. These machines had a time of 6 minutes, 18 minutes and 15 minutes respectively. So the cycle time, remember, was 18 minutes, but when I divided this by 6, the answer is 10, 30 and 25 machines. For M1 Ashwin, I need 10 machine. For M2, I need 30. For M3, I need 25 machines. These are the answers. These are the number of machines that are required in order to have a 100% efficient assembly line, as well as I will be able to deliver 800 units of product in 8-hour shift. So guys, before I bid goodbye to you, guys, remember, these YouTube classes are just to titillate you. We teachers, we educators try our level best to teach you on YouTube, but there are just simply too many constraints. Okay, I mean, please come to the Unacademy app. Please go to the Unacademy app. There we can teach with a lot more ease. We can have a proper communication. There is a real-time interaction between the student and the teacher. That is not the case on YouTube. You don't know how much difficulty an educator face just to go live on YouTube every day. I mean, there are multiple softwares that run on the background, and these softwares, they take different level of skills to manage. We educators do face a lot of trouble while coming on YouTube, not only while we are teaching you. That is a concern because time is a number one concern. Then the second concern is that we cannot interact properly on YouTube. The third concern, there is a delay, I mean huge delay. Whatever I say, it reaches to you after 30-40 seconds of time. Okay, Unacademy app is very fluid, very smooth. YouTube is an entertainment platform. Unacademy is an education platform. So guys, whether you go for the free package on the Unacademy or you go for the complete subscription package, that is the plus package, whatever option you select, please come on the Unacademy app to study. Okay, the special classes are also very fluid. So guys, let me just tell you that tomorrow morning at 8 a.m. Tomorrow morning at 8 a.m. till 10 a.m. sorry 10:15 a.m. there are two 60 minutes classes in succession, in consecutively. Okay, two classes consecutively will be there. Love you, Ashwin. Two classes of 60 minutes duration consecutively will be there on the Unacademy app in the category of special class. And guys, remember, I am currently taking transportation algorithm in these special classes. If you want to join that session, just simply follow me on the Unacademy app. I will be giving you the link here in the description as well as in the slides also. But guys, remember, it will be much more advantageous for you if you can go for the plus subscription. You can not only watch live classes, crash courses, you can give weekly tests. Every fourth class will be a doubt solving class specifically related to doubts, guys. English and Hindi, teachers will be teaching in both language. You can join various rank improvement batches where you will be specifically solving questions. And remember, if you can go for the iconic package, you will also be getting preparatory study material and a whole more. Guys, if you will opt for any of the subscription packages across the entire Unacademy platform, which permutation combination you choose, it will depends completely on you. But guys, please remember to compare the prices. The more the duration you will select, the money will simply get reduced. Okay, so whatever permutation combination you choose, whether it is a 3-month program, 1-month program, 6-month, 9-month, 18-month, 12-month, 24 months, whatever that it will be, remember to use the code, referral code M10. This is my code, Mote Manish Mishra. Okay, my friends used to call me MQ, so I decided why not use the referral code. So use this referral code and you can instantly have a discount of 10% across all the subscriptions available on the Unacademy app. Simply use the code M10, you will get the discount. And remember guys, you can also refer this coupon code, the referral code, to your friends also. Whether you choose the plus package or the iconic package, the M10 code is valid across all the Unacademy subscriptions available. So guys, up until then, let me just give you a bit more details. If you haven't yet followed me, just go to the Unacademy app, download the Unacademy app, select the GATE and ESE category and use this link to search my profile. You can simply connect with me by using this profile and just follow me on the Unacademy app to get future updates on my classes. This is my Telegram channel link, guys, the one in the red box. Take a screenshot of this link, type it in the URL, join this Telegram channel for the latest updates on my class schedule and also get the PDFs, notes, practice booklets and the necessary material for the GATE preparation of industrial OR. So guys, this is the Unacademy GATE Mechanical PIXC YouTube channel that I was live on. Up until then guys, thank you all very much for joining this session. Thank you all very much for joining this session. Remember, I will be live on the Unacademy app at 8 a.m. tomorrow in the morning and at 9:15 p.m. I will be again live on YouTube where you can watch me once again, where I will be starting a completely new topic. As we have completed line balancing completely, I will be starting a new series, a new lecture tomorrow on the Unacademy app. and on the YouTube channel also. If your friends are waiting for that, just intimate them, share the links of these YouTube classes so that everyone can benefit from them. Guys, please remember to like, share and subscribe if you haven't yet. Up until then, thank you all for watching this session. I will see you all tomorrow. Goodbye, good night. Love you all.